Hi everyone, it's Miss Berry. Um, in this video, we are going to go over section 8.4. That's our last confidence interval section, so I'm going to go ahead and turn my camera off and share my screen with you and we'll get started. All right, so I think you're seeing my calculator right now. Let me get the presentation started. Okay. All right, so this is our last section in chapter 8, which is called estimating population proportions. So here I just wanted to give you another example of how you could, sorry about that, how you could use confidence intervals. So instead of estimating population means, we'll be estimating proportions, which the definition of a proportion would be something that's like can be represented as a part over a whole. So I'll give you some examples of what proportions can look like. All right, so we have been using confidence intervals to estimate means. Um, I would like to show you today how you can use confidence intervals to estimate other population parameters, and one of those is a population proportion. So here is some examples where you may have seen population proportions or sample proportions in real life. So 4 out of 5 dentists surveyed would recommend Trident for their patients who chew gum. All right, so 4 out of 5 part out of a whole. 1,053 out of 3,000 students surveyed reported that they are non-smokers. If you've read any kind of scientific paper where they utilized a survey, you may have seen a sentence like this. And then this last one, I just wanted to show you they're not always represented as like blank out of blank, so part out of whole. You can also turn that easily into a percentage. So what they've done in this last one is they've just taken whatever the number was. So 1053 out of 3,000. Um, then they just took their calculator, clear that out. 1053 out of 3,000. So that's 0.351. That would be about 35%. All right. So you can also easily turn these proportions into percentages. All right. So this last one, I grabbed this out of a scientific paper that I saw that was published on some work that was done on Sapelo Island. So it says 53% of stained assemblages on Sapelo Island were found to contain the shallow water foraminiferan Hynesia germanica. All right, so you can also represent these proportions in their percentage form. So just like we saw in section 8.3, if we're constructing a confidence interval for population proportion, we have these certain criteria that have to be met. Of course, if you were doing this in real life, you would have to ensure that each one of these criteria were being met. In our problems, we're just going to assume that the criteria have been met. But here are the criteria. A simple random sample has been used, so we don't want something like a convenient sample being utilized. So we want to make sure that we have a true random sample. Next, it says that the conditions for a binomial distribution have been met. So this is going to be things like the trials are independent. The probability of success is the same in each trial. There's a set number of trials. The number of trials is more than 2. So you can go back to chapter 5 and review those conditions for the binomial distribution if you would like to. And then lastly, we need our sample size to be sufficiently large. And here are the conditions here that we would like to satisfy for it to be sufficiently large. All right, so you're seeing this new symbol that you've never seen before. So let me tell you what that symbol means. P with a little hat over it, we just call it P hat. So P hat. And this is the sample proportion. So some books use the Greek letter rho to represent the population proportion. Your book just uses P. All right, so if you see just a P, then that's the population proportion. Population proportion, that's the symbol for population proportion. And then if you're talking about the sample proportion, they call that p hat. P hat. All right, so in order for your sample size to be sufficiently large, remember in the last section we said it just had to be larger than, or 30 or larger. Here the criteria that we would like to be met is n times p hat, so that's the sample size, times the sample proportion should be greater than or equal to 10. And then the sample size n times 1 minus the sample proportion should also be greater than or equal to 10. All right, so your sample proportion here is in its decimal form or fraction form in this scenario. So your sample proportion is in its decimal or fraction form for that criteria. All right, so let's look at our example. So it says an automotive manufacturer wants to know the proportion of new car buyers who prefer foreign cars over domestic. Suppose that a sample of 351 new car buyers is drawn. Of those sampled, 87 preferred foreign cars. All right, so total sample size was 351, 87 preferred foreign cars. All right, so it says using the data, estimate the proportion of new car buyers who prefer foreign cars. Write your answer as a fraction or a decimal rounded to 3 places. All right, so p hat is our sample proportion or our estimate of the proportion. So if we're supposed to be estimating the proportion, that just means report the sample proportion, which we just learned was p hat. Whoa, that was a terrible handwriting. Try that again. P hat. Okay. All right. So p hat is just, you could think of it just like a part over a whole. So the part was 87. 87 people preferred foreign cars. The whole was 351. That was our sample size. I think if you're looking on the homework, they'll call this little formula, they'll say p hat is like x over n. So X they call the successes, just like with binomial. And then N is, of course, the sample size. So X would be the number of successes, I should say. All right, so X is the number of successes, N is the sample size. All right, so you can leave this as 87 over 351. If you prefer to write it in its decimal form, we can calculate that as well. They said 3 decimal places, so that would be 0.248. 0.248. Okay. All right. And now that we've got our estimate for the population proportion or our estimate for p hat, using the data, we're going to construct a 95% confidence interval for the population proportion. And we're supposed to round to 3 decimal places. All right, so let me show you how to get there. So grab your calculator. If you don't have it already, you might need to pause the video and grab it. All right, so you're going to go to the same place that we went to for the Z interval and for the T interval. So you hit the stat button, then go over to test, and you have to scroll way down for this one. Oh, there it was. 1 prop Z interval. 1 prop Z interval. So it's option A, 1 prop Z interval. So let's hit enter. And here's the things that it asked for: X, N, and C level. So X was 87. N, remember, X was the number of successes. So 87 people preferred foreign cars. N is our sample size. That was 351. Confidence level was 95. So 0.95. Then go down to calculate, hit enter. And there we go. We're supposed to do 3 decimal places. Oh, notice that it also gave us p hat. So if you wanted to, you could just, we could have skipped part A and went ahead and constructed the confidence interval, and it would have given us the answer for part A as well. All right, so let's grab these numbers, 0.203 and 0.293. All right, so 0.203 and 0.293. All right, 0.203 to 0.293. Same as last time, you just write these in the little parentheses, write them as an interval. All right, and I just wanted to make note here of how we got there. So we went to stat. We scrolled over to test. And then we had to scroll way down. And it ended up being option A. And it said 1 prop Z interval. 1 proportion Z interval. All right. And if we were interpreting this, remember we've talked about this every time that, depending on what statistical software you're using, whether it's Excel or the calculator or SPSS or SAS or R, it's going to be different how you construct these confidence intervals. So the steps, what buttons you click are going to be different, but the interpretation is always going to be the same. So it's important that we know the interpretation. All right, so we would say we're using that same template sentence from before. We are 95% confident that instead of the true mean, this time it's going to be the true proportion, or we'll say the true population proportion, that the true population proportion of new car buyers who prefer foreign cars over domestic, that the true population proportion of new car buyers there we go, who prefer foreign cars over domestic over domestic is between, that one had a long variable description. All right, so I'm going to round, I'm going to convert these into percentages just for interpretation purposes, but you could totally leave them as 0.203 and 0.293, but I'm just going to say that this is 20.3% and 29.3%. All right, so that the true population proportion of new car buyers who prefer foreign cars over domestic is between 20.3% and 29.3%. All right. Perfect. Okay. Here's another example. Very similar setup. We'll actually go ahead and construct the confidence interval this time since we already know that it's going to give us the sample proportion. All right, so it says the American Heart Association is about to conduct an anti-smoking campaign, and they want to know the fraction of Americans over 41 who smoke. Suppose a sample of 656 Americans over 41 is drawn. Of those, 538 don't smoke. All right, so this one's kind of tricky. They want to know the proportion of Americans over 41 years old who do smoke. This is how many don't smoke. So we need to do 656 minus 538 to figure out the number of people who do smoke. All right, so 656 minus, what was it, 538? I have the memory of a goldfish. Yep, 538. 118 did smoke. All right. 118 smokers. All right, so that's our, whenever we go and do our confidence interval, our X, our number of successes, that's going to be 118 smokers. Our sample size was that 656 that got surveyed. All right, so part 1 is to calculate p hat, and then part 2 is to construct an 80% confidence interval. So we're just remembering that number, 80%. All right, so same thing, clear out your screen, stat, go over to test, scroll way down to 1 proportion Z interval, 118, Was it 656? Yes, it was. 656. And then 80% confidence interval this time. All right, go down to calculate, hit enter, and there we go. We'll do 3 decimal places, I guess, again. So 0.161, 0.199. All right, 0.161, 0.199. And then there's our estimate for p hat. So that would be, if we rounded this to 3 decimal places, that'd be 0.180. Y'all know that there's no way I'm going to remember all that. All right, so I do remember that p hat was 0.180, so let's write that down. P hat was 0.180, which is about 18%. So we would say we're approximating that 18% of Americans over 41 smoke. All right, and there's our numbers, 0.161, 0.199, 0.161, 0.199. All right, and if we were writing a sentence to interpret that, we would say something like, we are 80% confident that the true population proportion, just copying the wording from the problem right here, that the true population proportion of Americans over 41 who smoke or that smoke is between, and we'll write our numbers in their percentage form. So about 16.1% and 19.9%. Okay. We're 80% confident that the true mean population proportion of Americans over 41 who smoke is between 16.1% and 19.9%. And once again, if you're good at English or literature, whatever, you're probably cringing at this sentence, but I'm sure you could word it better. Which would be totally fine as long as you get the the template down, the confidence level, the description of the variable, and then the values. You can word it however you want to. Okay. All right. So last thing for this section is you might think this looks familiar. This is our minimum sample size for estimating a population. Whoops, there's a typo there. That's supposed to say proportion. Proportion. My bad. All right, so this is the same thing that we did back in, I think this is the wrong formula. Hold on, let me pull up the notes. I think I must have forgotten to update the formula. Let's see. I can't pause the recording, so you're having to see this live. Sorry, guys. All right, here's our notes. Yes, see, I've got the wrong formula in there. Okay, so P times 1 minus P, P times 1 minus P. I better write this down so I don't forget. And then the critical value over the margin of error squared. Okay. All right, let's fix that. Okay. All right, so here's our formula. N equals P times 1 minus P times the critical value Z sub alpha over 2 over the margin of error E all squared. Okay. All right, so you can see that our table of our critical values is the same. Our formula is just slightly different. All right, so this again, if you recall from, I think it was 8.1, where we first learned about this formula. This formula is what you would use if you, like before you started your study, if you said, okay, I know that people in my field generally use a 98% confidence level. So that's going to sort of work backwards and tell you how many people or animals or whatever you're studying, how many you should survey. All right. So that's the idea behind this formula. And it's a very conservative estimate. So if you hit that mark, then you should be more than fine with this confidence level. All right. So it's a very conservative estimate. All right, so here's our first example. It says the State Education Commission wants to estimate the fraction of 10th graders who have reading skills at or below the 8th grade level. All right, so they're trying to estimate the proportion of 10th grade students who have reading skills at or below the 8th grade level. So that would seem to indicate that they are at a reading level that is below where they should be. And it says in an earlier study, the population proportion was estimated to be about 0.16 or 16%. If you wanted to do a new study, how large of a sample would you have to use to estimate the fraction of 10th graders reading at or below the 8th grade level at the 98% confidence level with an error of at most 0.03? All right, so there's our formula. I got it right on this page. Here's our our critical values. You can see I went in and found the 85% critical value for you, and I added it to this table. So you might want to add that to your table if you have copied that down in the past. All right, so our 85% critical value is 1.44. We're using 98 here, but I know that some of y'all will see 85% on your homework. Okay, so let's grab all of our numbers. All right, so P, that's our estimate for the population proportion. They said 0.16 from an earlier study. Our critical value, Z sub alpha over 2. For 98%, that's 2.33. And our desired margin of error was 0.03. All right, so let's plug those numbers in. All right, so we have N equals 0.16 times 1 minus 0.16. Again, I'm just looking up here at this formula and plugging in my values. All right, then another parentheses. My critical value goes in the top. Margin of error goes in the bottom. All that's getting squared. All right, so let's grab our calculator. Okay. Clear that out. 0.16 times 1 minus 0.1, oops, 16, close parentheses. Open another set, critical value over margin of error, close parentheses, squared. Boom. And remember the way that this works with the minimum sample size formulas, you always round the number up. You sort of ignore your rounding rules when you're doing the minimum sample size problems. So even though this one is 0.7 and we would have, traditional rounding rules would have told us to round up, even if it had been like 810.1, we would still round it up to 811. All right, so 811. So we would say that that's approximately 811. And again, this is 10th graders that we would need to survey. All right. And then our last problem. NASA is conducting an experiment to find out the fraction or the proportion of people who black out at G-forces greater than 6. In an earlier study, the population proportion was estimated to be 0.47. All right, so that's our estimate for P. How large of a sample would be required in order to estimate the fraction of people who black out at 6 or more G's at the 85% confidence level with an error of at most 0.04? All right, so confidence level is 85%. There's our critical value. So our critical value is 1.44, and then our error is 0.04. So let's plug everything in. All right, so our sample size n is going to be 0.47 times 1 minus 0.47. Critical value goes in the numerator, so 1.44. Error goes in the bottom, so 0.04 squared. All right, grab your calculator. 0.47 times 1 minus 0.47. 1 minus 0.47. Parentheses, critical value was 1.44. Lots of fours in this one. Error was 0.04. And then close the parentheses, square it. Boom. All right, and again, whatever the number is, round it up to the next whole number. So that'd be 323. 323. So approximately 323 people. So they were just surveying people. They didn't give us any specifics on the age or gender or anything like that. So we'll just say people. Okay. All right. Let me switch back over to my screen. Hello. Oh, okay. So that was everything for this section. I hope if you have any questions that you'll let me know. Otherwise, I'll see you guys in the next video. Have a good one.